Your final day of AZMerit review, here's the problem. And many of these questions are going to be in the form of if you were given an AZMerit test that was completed on a computer. At Trevor Brown, we don't have enough computers for the number of students that will be taking the AZMerit, so you will be taking the test in a booklet. And in my opinion, that's actually easier for you. You can flip back and forth if you're on the computer. It's hard to go from one problem back to another if you want to change it. So I think it's actually a better thing for you. But sometimes how the questions are worded makes it a little difficult because remember, this is set up for somebody who's taking it on a computer. So the first one says, the graph of y equals x squared is shown to the right. They want us to drag this shape, this parabola shape, they want us to move it to fit this translated quadratic equation. Y equals x minus 4 squared plus 2. You're going to turn to your partner, you're doing nothing on the paper right now, and you're only going to say, what would you do to this shape to now make it into this, to represent this equation? 5 seconds, go. Son, share with me what you would do. Move it to the right 4 and up 2. Nick, do you agree? He said move it to the right 4 and up 2. You agree. So everything here would just go right 4, up 2, and I would draw the same picture, and we're done. Thumbs up or thumbs down if we're understanding that concept. Some of us are not doing anything, so I don't know if you're understanding or not. Thumbs up, I get it. Thumbs down, I'm not getting it. Okay, make sure your partner, if your partner is like this, that you're explaining it. Again, each one of these points that represent this shape would all be moved to the right 4 and up 2, and then it'd be redrawn again. Okay, next problem. Please do second plus 712, so when we get to some graphing problems, nothing is in the calculator. Here's the second problem. Second problem says, you have the options. So again, this is on the computer. These are the options they give you. One of these is the final answer here to represent the exponent on the x. They want you to simplify this and tell us what should be the exponent. Please don't say it out loud. You're working with your partner. You have 30 seconds. Go. I would pick up a calculator. When you have the same base and you're multiplying, you add the exponents. This is the cube root written as 1/3 plus 3/2 plus -5/6. On the bottom, remember there's a hidden nth root of 2. This is x to the 1/2 power. So again, when you have the same base and you're multiplying, you're going to add the exponents. So we have 1/3 for cube root. Plus, next one is 3/2 plus -5/6. Math fraction, enter, enter. Whoa, I must hit something wrong here. I forgot a 3. Let's try it again. 1/3 plus 3/2. You can't see anything? Thank you, Diego. Plus 3/2 plus -5/6. Math fraction, enter, enter gives you an answer of 1 on top. So I have x to the first over x to the 1/2. Now you're going to subtract top, subtract bottom. 1 subtract 1/2. You should know this in your head. It gives you an answer of 1/2. This is the correct answer. Turning back to your partner to make sure they understand how to get that. Ready? Go. So if you can't see, you need to move towards the center. Okay, there. Anna, did you hear me? Thank you, honey. All right, next problem. Okay, challenge problem. You ready? Not one student, they've all made a small mistake. Not one student in periods 1, 2, 3 has been able to come up with this answer. This was taken out right when I got back from maternity leave. You have been working with Miss We got a crazy in the back. We've been working with Miss Graybill, and this is a polynomial. So I want you to use these to use these as options, and I want you to construct what polynomial you believe this is. Work with your partner. You have 30 seconds, and we're going to go over it. Ready? Get set. Oh, let me bring it back so everybody can see it. And go. Who feels confident? There's no penalty if you're wrong. Okay, Diego, I'm ready for you. Go.
X plus 3.
Slow it down. Okay, x plus 3, okay?
X plus 1.
Okay.
And x minus 4.
All right. Thank you, Diego. Ulysses, do you agree or disagree?
I agree.
You agree. Okay. How many people agree? Hands up high. Does anybody disagree? Does anybody have a different answer you think it could be? This is not correct.
Oh, no.
That's all right. Thank you for offering. Daniel, what do you think it is?
X minus 2.
Okay, slow it down. So give me the whole answer.
X plus 3. X plus 1. X minus 2.
X minus what?
2.
Okay.
And
X minus 1?
4.
4. Sorry, I could not hear you. So you believe this is the correct, Daniel. Is that correct? Yes, here. You believe this is the correct answer, Daniel. Okay? Raise your hand if you agree with Daniel. Nobody agrees with you, Daniel. Okay, Pedro agrees with you. Pedro agrees. Okay, Ricardo agrees. Okay. Daniel's not right. Daniel is closer, and he's just one thing off. There's only one part. Yes, Anna has an answer. Okay, Anna. Okay, let's slow it down. What do you think it is? Okay, slow it down. X squared minus 4 and x squared minus... Okay. Do you agree with that, Pedro? Yeah. No, does not agree. Okay, the closest one is Daniel. We're going to go back and do a quick review, and then you're going to come back and you're going to get this. You ready? I'm going to make up my own problem. Please watch. Each one of these increments represents, don't talk when I'm talking, thank you. Each one of these increments represents one space to the left or right or the origin, okay? So I'm just going to draw a random polynomial here. Bless you. Okay, this is a weird shape polynomial, but let's go through this. Do you remember the word multiplicities? Multiplicities? We said even or odd. Servando, do you believe this is an even or an odd multiplicity? Right here, look up at the board. Odd, you're right. Do you believe this is even or odd, Isaiah? Even. This one right here, Leslie. Odd. Last one, Ricardo. Even. Okay, does everybody understand what the difference is? If it cuts through, it is odd. If it bounces off, either on the top or on the bottom, it is even, okay? If something cuts through, we represent it one time in our final answer. If something is even, we have to represent it twice. So let's go back to what Daniel said. So -3, okay? He represented a 0 of -3 with x plus 3. That is correct. It is odd. He represented it correct one time. The 0 is at -1, so he represented it with x plus 1. It was odd. He represented it once. That's correct. This is even, so he wrote it as x minus 2, which is right, but because it's even, there has to be 2 of them. And and a 0 of 4 should be represented one time because it's odd, and you represented that correctly with x minus 4. So this is the correct answer. The only thing we forgot is because it's even, you have to represent it twice. Please talk to your partner to make sure they understand. Go ahead. Can somebody please walk to the back? Okay, that person just left. Diego, just ask what they need. I think it's freshman looking in.
What? They have books?
Oh, sure, they can walk them in. Yep, thank you. Thank you, guys. As soon as I start to draw this polynomial, you're going to come up with an equation. Can you set them for me right on the side? Thanks, guys. Okay, there's the equation. I'm trying to trick you. Be careful. Work with your partner. Go. I don't think you're going to get this right because I'm trying to trick you. Be careful. Thank you once again. I'm seeing good talk with your partner. No penalty for a wrong answer. Take a risk. David, know that I'm not calling you, okay? Right or wrong answer, I don't care as long as you try, okay? 10 seconds left. Okay, David is going to give us what he believes the answer is, and then we'll analyze it as a group. David, go ahead, please.
X plus 3 squared.
Okay, can you tell me why you did that? Even multiplicity, keep going.
X plus 0. X minus 4 squared.
Okay, Sergio, do you agree with that answer? Correct. Do you agree with that answer, Leslie? This is correct. This is correct. Another way to write this, by the way, is adding 0 going to change anything? So if you just went like this, that's fine. You didn't have to do the plus 0, but the plus 0 just shows David he understands it. But what I thought a lot of students would do is they would completely forget about that and they'd only have this as their answer. I thought over half of you would do that. Be honest, how many of you forgot about the 0? You guys are lying. Thank you for being honest. Okay, you ready? We're moving on to the next problem. You're going to do this problem on your own. And as soon as you have your answer, I'm going to walk around. As soon as you have your answer, just raise your hand and I'll come over. My goal is for you to get the answer. Some of you are going to just do this in your head. My goal is for you to get this on your own in less than 30 seconds. This is more like an Algebra 1-2 question. Okay, so you are going to answer the final question right there. Ready, get set, and go on your own, no talking. Okay, for vision reasons, some people can't see, so I'll read it out loud. A car rental company charges customers an initial charge plus a daily charge to rent cars. The initial charge is $30 and the daily charge is $25. The rental company charges Jacob $180. Create an equation that can be used to find the number of days Jacob rented the car and then solve the problem. Go ahead. Charged him initial charge of $30 and a daily charge of $25, and then at the end, the final bill was $180. So you're going to raise your hand when you have an equation, you have an answer. Okay, color right here. What's your answer? You got it. Got it? You're good. Yes, check it. Good? Good check. Good check. Now solve it. Okay, now solve it for me. What's changing is the number of days. This is a linear equation. What's changing is the number of days you rent it. What will stay constant is how much you initially have to be charged. So this is what your final bill will look like, okay? It will be composed of these two things. Now you get your final bill and it's $180. So to solve for D, you first subtract 30. After subtracting 30, you have 150 equals 25D. You divide by 25, you get an answer of 6. So they would have rented the car for $6 if this was true. Talk to your partner, because I know not everybody got it, to make sure you understand. Not $6, 6 days you rented a car. I may have said the wrong term. So, within standardized tests, if you can get an answer, not have to show all your work and use kind of common sense within mathematics, that's great. So, there are 6 different problems here, and I want to know which one of these results, and there may be more than one, in a final answer that is an integer. Remember, integers are like -3, -2, -1, 0, 1, 2, 3. Is 8 divided by 2 an integer? No? Do you guys agree? 8 divided by 2 is not an integer. Servando, do you agree? Is 4. So then is 4 an integer? So 8 divided by 2 is an integer. Is 8 divided by 3 an integer? No, because it's ugly decimal, right? So if you have a fraction, you want to divide it out to see, do you have those pretty whole numbers that are both positive or negative, okay? All right, you ready? With your partner, you have 6 to test, and I want you to use common sense. I am stopping you after a minute and a half, maybe even less than that. Ready, get set, go. Circle the ones that give you nice answers, nice integer answers. Thank you to those that are working well with their partner. Hearing a lot of good mathematical dialogue. Further, I have a few groups here that are not working as well together. You're sharing with your partner. What's the easy way for you to tell right away? Yes, it's going to be a nice answer. No, it's going to be one of those ugly decimal answers. Okay, gonna stop you, right? Let's use some common sense. Grab a calculator, please. We'll use it when we need to. I will tell you, sometimes by me using words like pretty or not pretty, I've confused some students unintentionally. So when you see an answer like 2, you know that's pretty, right? Yeah. But when you see 0.5, even though it's not an ugly decimal, 0.5 is still not an integer, okay? Here we go. Square root of 64 is 8. If you take 8 and add 3, do you still get a nice answer? Good works. Good. Okay. Square root of 20, is that nice? No. Reminder, square roots that are nice are going to be perfect squares. Square root of 4, 9, 16, 25, 36. 20 is not nice. It's not nice. There's nothing you can do to it to make it pretty. It's done. Square root of 16 is 4. Let's not worry about reducing anything right now. So I have 4 over 8. Now to eliminate a square root, I'm going to square both sides. So don't worry about reducing. Put 4/8 in parentheses and square it. I don't care what your final answer is. Don't tell me. All I want to know is that number an integer, yes or no? Done. Okay, square root of 39, is it pretty? Now, to eliminate a square root, we're going to square both sides. Please square 75. Now, to isolate the x, you're going to divide both sides by 3. Don't tell me the answer, just answer yes or no. Is it a nice integer? Yes, ma'am. Square root of 100 is 10. To isolate the x, we divide that by 2. 10 divided by 2 is 5. It is an integer answer. Before I move on, make sure your partner understands. Okay, you ready? If I asked you to graph something, before I even give you an equation, if I asked you to graph something, you'd want to be given ordered pairs that were pretty easy to graph, right? So if I gave you an ordered pair of 2, 1, is it easy to graph? What if I gave you an ordered pair of like 2 and 0.5? Is that still easy to graph? So this particular problem is going to give you an equation. It's going to say, I want you to graph this by showing me 3 solutions. That means 3 points that are along that line. Well, we need to be able to provide 3 solutions that are nice answers. So we're going to do this as quick as possible. Do second plus 712. Go up to y equals, and please insert the equation you see for this problem. Then hit graph. Ben, I'm going to put you on the spot. When I look at this graph, I can see that as it goes to the right, it's going to get closer and closer to this line, the x-axis, and it's going to get closer and closer as I go to the left to this line, but it's never going to touch those. What are those lines called, Ben? Asymptotes. So the horizontal asymptote is at x equals 0, and, the vertical asymptote is at x equals 0. The horizontal asymptote is at y equals 0. It will never cross those 2 lines. So this has come up with 3 solutions. Well, how do you do that? Start by hitting second table. We're going to just move throughout this, and we're going to find what looks like nice numbers. Do you agree that 1 and 3 would be a nice point? Yeah, it'd be 1 if we're done. I'm going to keep going. Do you agree 4 and 1.5 would be easy to graph? It's exact. It's not rounded. Do you agree 9 and 1 would be nice? Easy. So I put those 3 down, and I'm done. Make sure your partner understands how to get to this table, and then we'll move on. All right, so this has been a fun problem for me to do with the classes. So there is a difference when we talk about probability between the word or and the word and. Now, although this is not true, I want you to listen. If I said to you, anyone who is a freshman student or wears glasses may leave early today. Please stand up if that criteria meets you, please stand up. Anyone who is a freshman student or wears glasses, please stand up. Anyone who, that's all I'm saying to you. Okay, so my question for you is, why the heck is Pedro standing up? He's a freshman. Why is Son standing up? He has glasses. Sit back down. Now, here's the key. You ready? Listen closely. If I said to you, anybody who gets to leave early today who is a freshman and wears glasses, stand up. Okay? Do you see that not only are they freshmen, but they also have to wear glasses? And means both, or means either one. Okay, sit back up. Are you talking about bowling in here? Now Ricardo's going to cry, and I'm going to have a mom call me, and she's going to be speaking Spanish, and I can't answer back. It's going to be horrible. Okay, here we go. So when I've called on students, it seems to me that like a quarter of the students get this right away, and after 3 times you still have students who don't get this. So that's okay. We're going to understand this, but I don't want to just tell you the answer. I want to see if you can formulate your own understanding. This says that a teacher has a classroom with 30 boys and girls. It doesn't tell you how many are boys. It doesn't tell you how many are girls. The class has both 9th graders and 10th graders. So you know that you have both 9th graders and 10th graders in a class, and you know you have both boys and girls. That means each one of these boxes will contain a number. The probability of randomly selecting students from a class that are female or a 9th grader is equivalent to this fraction. So we're going to make tally marks. There can be all kinds of different ways to represent this. We're going to make tally marks that represents this statement. Okay, so you ready? Just pay close attention right now because I'm going to call on 4 different students. We're going to start with Daniel. Daniel, in this box, I want you to give me a number that would work. There's many different options. Give me a number that works. Daniel says 9. Ulysses, in this box, give me a number that works. 4. So by the way, how many kids have we accounted for so far? 13. But how many total are there? There's 13 accounted for, we have 30, okay? Now I'm going to give you a really hard one. Are you ready, Itzel? In this box right here, there is one number that works at this point, Itzel. What do you think this number is? Please do not answer for her. 6. Do you agree with that, Fernanda? Can you give me your reason why you agree? Okay. Fernanda, do you agree? Okay, so you're a little confused. Thank you for your honesty. Sons, do you agree? Why are you sitting together? What's happening? Okay, 4 eyes in front. Do you agree? Oh my gosh, they all have glasses! I'm joking. Sergio, do you agree?
Yes.
Why do you agree?
Because it equals up to 19.
It equals 19. Did everybody hear that? Okay, you ready? I'm calling on Jasmine next. Jasmine, there's only one number that works. Do not answer for Jasmine. And Jasmine, don't feel bad if you don't get it. We have 2 that have already admitted. They're a little lost. Okay. Jasmine, what number do you think goes here? There's one number that works. Giselle, do you have a guess? Nick, do you have a guess? 11. Okay, you ready? Giselle and Jasmine. He is correct. How the heck did he come up with 11 and only you 2 can answer? It all has to add up to 30. Did everybody hear that? Yeah. Okay, great. Now watch again. Ben, right here. Tell me a number. Number that has to suit this. So you tell me a number. So 6. Okay? Sons, tell me a number. 9. We're videotaping this right now, sons. Servando, tell me a number. Does that work? Why does that work, Servando? 19. What goes right here, Giselle? 11. Okay, thumbs up or thumbs down if you're understanding right now how we come up with these. Okay, stop. Give yourself 10 seconds to not talk about 2 of these numbers, but to talk about how we came up with these numbers right now to make sure everybody understands before I go on. Go. Okay, we get quiet in 3. Self-control in 2. And in 1. Okay, you ready? I'm gonna change it this time. I'm gonna cross out this word or and I'm gonna use the word and. If I had you come up with a fraction that represented females and freshmen, turn to your partner and decide what number would be in the numerator position and what number would be in the denominator position based on this data. 5 seconds, go. Okay, Diego, what do you believe? 9 over 30. And by the way, if you're looking at a multiple choice test and 9 over 30 is not there, it would be because it's not reduced. So that would then equal 3 over 10, okay? If that option would. Now, how did Diego get that? When you use the word and, it has to fulfill both. So both freshman and 9th grader, the number is 9. The total number is 30. Nice job. Okay, go ahead.
You know how,
Do you want to talk about and or?
or,
Okay, got it.
you know how I said that it's female or in grade 9?
Uh-huh.
How did you, like, come up with the 9 female and
You choose any number that you want, but these 3 numbers have to add up to the top number, which represents those 3 things. So you could have said 1, 1, and 17. Okay, as long as they add up to 19. Yes, go ahead.
For and, why is it 9 over 30 and not 19?
because it has to represent the entire group. The bottom represents your total population.
So, doesn't that mean that there has to be 19 female and freshmen?
No, because great question, Pedro, it can't overlap. So do you see how this position, when we use the word or, it overlaps? It counts for both females and it counts for ninth graders? Can't overlap. So go back and say it again, Pedro, just I want to make sure to answer it. What's your question once again?
Because isn't it, if it's female and blue glasses, they would have, oh wait,
We're okay?
yeah.
Okay, you sure? Okay, Servando, did you have your question answered? Okay. Great, here's next. All right, so this is a problem that I want no more than 5 seconds spent on. You're going to read it to yourself, turn to your partner, and answer. Read as quick as you can, and then I'll start counting. Right now, this is where these are sitting. What would be the ordered pairs for the A and the B after the translation? Your 5 seconds starts now. Go. 5, 4, 3, 2. Joseph, this is at the origin right now. Okay, it's like your initial value for the square root function. What is going to be the ordered pair for A after it's been translated?
2.
Letting just Joseph answer, please. 2, 3 is great. 2, 3 is right. That's a little bit easier. This is currently at 4, 2. At 4, 2. Okay? Leslie, shh, ladies. Leslie, what does this become after it's translated? Nice job, Leslie. That's a lot harder. 6 and 5. There we go. Done. Make sure your partner understands before I move on. I think most people have been able to understand that. Whoever enjoys reading between you and your partner, you're going to read this problem out loud, and then we'll talk about it. Go. So if this problem was done on an actual computer, you would have some ability to put a point on the line that represents when this insect is at the greatest distance from the starting point, and then actually when it lands back at the starting point. Now, the misconception I hear from students is they think the bug goes like this. They think this insect starts and then it actually makes this shape when it's flying. That is not true. Easy to think that though, okay? So we're going to say this insect is a little bit strange and it only flies in one line. It's going to make a little more sense to you. So this is the starting point. Okay, after 1 second, approximately how many meters is it away from the starting point? Okay, so I'm going to say I just take a meter step each time. So here's 1, 2, 3. Nick, hold this right here. You have to stand up, Nick. Okay, so after 1 second, that's where the insect is, okay? And we're just going to say for our purpose, it only goes in a line back and forth. After 2 seconds, has that insect started to come towards the starting point, or is it going towards them? So slightly towards. Nick, come just a little bit this way, just slightly, okay? After 3 seconds, which way is it coming? Towards. A little bit more, Nick. After 4 seconds, a little bit more. Does everybody understand this? Then what does it start to do? So keep going back, but then once it reaches, keep going like back to then. After 7 seconds is at then, and then what does it start to do again? Come all the way back until it touches the wall. Does that make sense? So tell me when to stop, and I will stop with my finger when you see the point on this graph where it is furthest from the starting point. Understand? When does it come back to the starting point? Make sure your partner understands. How many of you pride yourself in common sense? Hands up high.
Probably not.
All right. So Ms. Graybill already informed me that many of you were zoning out yesterday during the video. Look at the little sassy bug over there who's a freshman. Okay, realize if you're going on to pre-calculus next year, there's no direct instruction, it's all videos. Okay, you need to be a little more self-motivated with this. So this is based on what you would have reviewed yesterday. All right, ready? 3 classes, not one person is able to come up with the answer. But let me first share with you this. I'll read it to you, and then I'm going to give you a little bit of hint, and then you're going to work with your partner. Put your calculator down. None of this will you use a calculator for on this problem. The height of adult women in the United States is normally distributed with a mean of 65 inches and a standard deviation of 3 inches. Click on the number line that shows the vertical line that approximates the height of 25% of the women that are shorter and 75% of the women are taller. So you're going to click on one of these numbers. It's not going to be like 56.5 or 69.25. It's going to be on one of these numbers. Okay, it will be a whole number along this line. You have 1 minute. While you do that, I'm going to pass out a few apples, and then I'll go over it. Not one person has been able to get this. Ready? Work with your partner. Go. Leather.
Oh, no, it's bad.
David just asked for more. David, no, eat what you have right now. Uh-oh, I'm running low. Apples? Running low. Apples? Uh-oh. Don't be like throwing these on the ground, David. Watch it eat them. Really? I'd say more like flavored but healthy leather. Okay, here we go. If you're wrong, that's okay, but I would like to know what is your reasoning, how you came up with the number. And you're just going to use logic to get this answer. Does anybody have an answer? What do you think, Pedro?
62.
You believe 62. How'd you get that?
Because below 62 is 25%.
How'd you come up with that?
Because 13.5 plus the other number.
Okay, so I'm hearing you say 13.5 plus 2.5 is 16. That's not 25. Okay, that's all right. I'm just questioning. What did you get, Diego?
I want to say around like 59-ish.
59. Okay. Ulysses, Daniel, did you guys get anything? 63. What's your reasoning? Okay, so you are literally going to guess on this, but you're going to use the logic based on what you know. Okay, ready? Hopefully at this point, I have failed you if you've been in class and you don't know this. If you're in class is the key. Do you remember that the mean goes right here?
Yes, ma'am.
Do you remember that the mean cuts this shape directly in half? So under the curve is 100%. Well, if you cut it in half, you're at 50%, correct? We want to find a line that when I draw that line, let's say it's a pen, when I draw that line, to the left will represent 25% and to the right will represent 75%. So am I going to be working on the right-hand side or the left-hand side of this middle line? To the left, right? Because I want 25% over here. We already know this is at 50. I need to go to the left. So a lot of students forget. Do you remember how a lot of times on our work we would see problems like -1, -2, -3, 1, 2, 3? Well, to get those numbers, those z-scores, we have to use the standard deviation. So I'm going to go 3 to the left, 1, 2, 3. I'm going to go straight up. That's your z-score, by the way, of -1. This is 34%. 1, 2, 3. This is 13.5. 1, 2, 3. This is 2.35. 1, 2, 3. This is 0.15. What I heard Pedro say, he was on the right track. I was just questioning his thinking. What does this add up to, sons? 2.5. Remember, it's cut in half, sons. So it's okay. So 2.5 and 13.5. Tell me what you get, guys. 16. So listen to me right now. Up to this point is 16%. Up to this point is 50%. What number do I want to go up to? 25. Well, the cool thing is in between here, because of the standard deviation, is only two options. The only option is 63 or 64. Now, is 60, this is not a linear line, keep in mind, is 25% closer to the 16 or closer to the 50%? 16, option 63. Does that make sense? Now, for those that paid attention, you saw this in the video. Did you see me do this? Where you went second, vars, CDF? And then negative 999, okay, comma, what number did we decide on? 63? What's the average? 65. What's standard deviation? It should be around 25%. You could also use guess and check. So you can do guess and check with those numbers. Thumbs up or thumbs down? That's a tough problem. Thumbs up, thumbs down? Okay, remember this video will be here for you. All right, let's go on to the next one. I'm going to speed it up right now. Who can throw a baseball up in the air? Let's go, hands up high.
Throw it in the air.
Yeah, there we go, Diego. Okay, ready? I'm speeding right up right now because I have 6 minutes and we may not get through everything. You may have to stay after a minute or two, so you got to be quiet. You ready? Here we go. This is what this word problem says. It says that this is the pathway of somebody who threw the ball up in the air. And then it says a second person's going to throw the ball up in the air. This is Diego. By the way, let's check out how high is the ball when it releases from Diego's hands. It's between 4.5 and 5.25. So it looks right about 5. Does everybody see that number? So it releases 5 feet above the ground. It goes up as high as 9 feet in the air. Then it comes back down and hits the ground. Can you thumbs up or thumbs down if you understand that concept? Okay, you ready? So now a second person. We have Servando. He throws a ball up in the air. Now, where he throws the ball has to be at a lower initial height. So is it going to be above 5 or below 5? Below 5. Now, this goes back to an Algebra 1-2 concept or something that Ms. Graybell went over with you. This number represents your initial height. So can I consider this equation? Yes. Can I consider this? This one? This one? Yes? No. So I've already eliminated 2 of the 6. Now, before we even get to the next problem, when Servando throws a ball, it's going to be the same pathway. It goes up to a certain part and comes down. It's a parabola that goes upside down. Ulysses, any parabola that goes upside down, what can you tell me about it when you look at the equation?
It's
Negative where?
the x squared.
Yep, negative in front of the x squared if it's going to be in this general direction. So it's negative, it could be that, not negative. Negative, it could be that, not negative. Now listen closely. Grab your calculator. Second plus 712. The person on the left-hand side, please plug this in. The person on the right-hand side, please plug this in. The person on the left-hand side, plug in the first. The person on the right-hand side, plug in the second. You can sit next to someone, Ben, since we're down on minutes, okay? Okay, you ready? It says that when Servando, the second person, throws the ball up in the air, the maximum height must be higher than the first person. Diego threw the ball up 9 feet. So which one has a maximum height that's greater? So you're going to do, after you graph it, you're going to do left bound, right bound, second trace, maximum, left bound, right bound. And you're going to find out that one of them is far below 9 and one is slightly above. And this is the one that is slightly above. Does anybody want me to graph it to show you? No? Okay, I'm sorry, we're low on time here. We're going to move on to the next one. We're going to do common sense here again. Okay, eyes up here. You're going to write nothing down. You're not even going to use a calculator. Eyes up here. So we're talking about exponential equations. We have 2 different funds. We're going to put money into 2 savings accounts. Remember, the savings accounts, it's not like a stock market. You're not going to gain money and then lose it, okay? So a savings account is just going to slowly gain just a little bit of money each time, okay? So think about the rate and the initial amount. based on your knowledge of exponential equations, what's the initial amount you invested into this savings account? 500. It's your initial amount. It's your y-intercept. Now this is a different savings account. How much did you invest here? So both of them have a y-intercept or an initial value of 500. Look at your four options. A and B say same initial amount, same y-intercept. C and D say a different amount. So which two can I cancel out? Okay, Benjamin, I'm going to throw you on the spot. It says 1.015. Turn that into a percentage for me, Ben.
101.5.
Thank you. Turn this one in, Ben. Okay, so which bank account would you rather have money in? The one that gains at 105% or at 102.1%? Because the higher percentage, the more money you're going to make, right? So between these two, I know G is going to gain money at a larger or quicker rate over time. There's your answer. Turn to your partner, make sure they understand. Okay, this is a freshman level problem. We have two left. Let's see if I can get at least one of the two done. This is a freshman level problem. I'm going to look at good intersection points. There's a couple different ways to teach this. I'm going to look at good intersection points. So if this was zoomed in, you'd see that this crosses at 0, 1, at 1, 2, and at 2, 4. Okay, I found good intersection points. Now I want to come up with an equation. Remember, it's your initial value and your rate raised to the x. So the initial value, where does this cross the y-axis? I'm going to ask that when the bell rings. Let me at least finish this before you leave. Okay, you ready? To find out the rate, here's one way of doing it. You divide as long as these are consecutive. 4 divided by 2 is? 2 divided by 1 is? This is your equation. Don't leave. What this means is plug or substitute 6 in for x. 2 to the 6th power, go. 64 times 1 is? See you later. Have a great day. On this video, I'm going to go over one last problem for you. And I'm going to use a calculator to demonstrate this. So it says that we have an equation where y equals a times x plus b, absolute value of x plus b plus c. And we're going to use these values and substitute them in for the open spaces, right now, okay? So it says we have Kyle's claim, Sandy's claim, and both. All right, so let's first just review what absolute value equation looks like. So an absolute value equation creates a shape that's like a V. And so the parent value of absolute value looks like this. It cuts through the first quadrant and equally through the second quadrant. Reminder that anything within this region, so like a +3, we're going to go move to the left 3. Or a -2, we're going to move this whole thing, translate it to the right 2. Anything behind here, like a +4, we're going to shift the entire thing up 4. A -4 shifts it down 4. The number in front will either stretch it, vertically stretch it, or compress it. If it stretches it, it's just going to get skinnier. And if it compresses it, it will be a wider V. If this number remains positive, it will continue to be a V that opens upward. And if it is a negative number, it will be a V that opens up downwards like so. Okay, so keeping that in mind. It says Kyle claims that he can come up with an equation that will have 2 roots. It will always contain 2 roots. Well, right now, when you look at this parent function, it contains only 1 root. And remember, another word for root would be x-intercept. So Kyle says I can come up with 2 x-intercepts, and right now there's only 1. So there's 2 different ways that we can write an equation or fill in these 3 spaces to represent how you could possibly come up with an equation of absolute value that has 2 roots. One way, if I would take this thing, and I don't care if you translate it left or right, but if you translate it down, you can see that you now have 2 roots instead of just 1. So if it remains opening upward, which means this has to be positive, any positive number, doesn't matter if it's going to be stretched or compressed. If this remains positive, so it opens upwards, and I don't care if you move this to the left or to the right or remain at the center, So this number does not matter. But if you shift it down with a negative number, you will come up with a function that has 2 roots. Another option, so here's your parent function. Another option would be to shift it up. So I'm going to take this point and move it up, but instead of it opening upward, it's now going to open downward. And here would be your 2 roots. So in doing so, I have to have a number in front that's negative to make sure that it opens up downwards. I don't care if we shift this to the left or if we shift this to the right. Makes no difference. We'll still continue to have 2 roots. So this number can be any number again. And then instead of shifting it down, we shift it upwards. So to shift up, I need the final number, or the number in back, to be a positive number. Those would be 2 options. Negative, this number does not matter, and a positive, or a positive and a negative. And you can always grab a graphing calculator to see, does it work? So I'm going to plug in one right now. We're going to start with the negative. So if I do, let's try -2. Then I'm going to get the absolute value by hitting math, number, absolute value. Remember the number after the x I said really is irrelevant. And now if I start with a negative, I need to have a final number in back that's positive. So let's go +5. I'm claiming that I'll get 2 roots from this function. There's one, and there's the second. Let's try another option. This time I need a positive in front, a negative in back, and this number again is irrelevant. So a positive in front, and then let's go, let's try a different number. So +3, math, number, absolute value, and I'll do an x -1. And this number has to be negative. This number has to be a negative. So let's do a -3, a -2. Here's the second function, and it shows again that we have 2 roots, 2 x-intercepts at this position and at this position. Okay, done with Kyle's claim. Now let's go on to Sandy. Sandy says she claims that you can come up with an absolute value equation that has no roots. Let's say Sandy claims that this equation will always have 0 roots, so it'll have no roots, no x-intercepts. So if something has no roots, it will never cross the x-axis. Here's our initial function once again. So here's my function, and I'm going to do this twice just so we can see both right away. Here's the parent function of y equals the square root of x, and there's only 2 ways to translate this to have no roots. One is simple. Let's just move it up. Again, you can translate it to the left or right, so you can shift it left or right, but as long as you move it up, this new function is never crossing the x-axis, resulting in no roots. The second way is not only to shift it down, but once you shift it down, instead of it opening upwards, it has to open downwards. This new function will never cross the x-axis. So in this translation, I moved it up. So I have a positive value at the end. This number is irrelevant. I moved it up and it remains positive in front so that it opens upward. In the second scenario, I moved it down, so a negative number in back. Again, this number is irrelevant. And once I moved it down, it can't open up. If it opened up, we can see that it would cross over twice. It needs to open downwards. The number in front needs to be negative. Let's show on the calculator quick. I'm going to make this one negative and this one negative, and I'll make this one positive and this one positive. So negative, negative, positive, positive. Never crosses, never crosses. Both examples of no roots, no solutions, no x-intercepts. Done with Sandy's claim? Now on to the last one. So this last one, part C, says Kyle and Sandy we want to show an example of where you can create, we want to show an example where you can create an equation that has exactly one root. So to have exactly one root, here's my original. This currently has one root. And the only way to remain with having one root is to have this shape, this absolute value function, regardless if it's a skinnier absolute value, it's been stretched, or if it's been compressed, it can touch at only one place. So the number in front that determines how wide it is, that can change, and it can open up or it can open down. So the number in front can be positive or negative. This can be positive or this can be negative. And it can translate to the left or it can translate to the right. So this can be both positive or negative, doesn't matter. But what matters is this number in back, it cannot be shifted above or below the x-axis. So this must remain at a 0. So we'll say this is negative, it moves to the right, never moves off the x-axis. It's positive, it moves to the left, this time it moves to the right, never moves off of the x-axis. These both should be examples of functions containing one root, one x-intercept, one solution, one root, one x-intercept, one solution.